Oh, the picture is there. So Ray Rally happening outside. I'm stuck inside recording math videos because my job. Uh, Eating some M&Ms. It's a good afternoon. All right, so we're gonna cover the quadratic formula in this lesson. You should have had the quadratic formula in Algebra 1, but it's a bit of a behemoth in terms of formulas. So we're gonna go through it. I'm gonna show you how I would like to see your work done, preview what the homework template looks like, and then you should be good to go. So, what can we do when square roots don't work? So we looked in the lesson, I think it was 2 lessons ago, about solving quadratics, and we do it by taking that square root. Okay. Now we know that works when you have an a value and a c value and b is equal to 0. But what do you do when you have that b, when you have that x term? So the answer to that is this thing called the quadratic formula. Now, this is kind of a cool factoid, all right? Typically, math teachers will just give you this formula, and nobody ever tells you where it comes from or why it works. It actually comes from that process of completing the square, where you have all the pieces and then you form a square out of it and then you see what's left over. And what you do is you make it like a algebra process where instead of having the tiles, you say, well, what if I don't know how many tiles I have? What would this look like? And you do it with the A, the B, and the C. And eventually you're able to solve that for X. So it's actually pretty cool. I do have some videos that will take you through the process of where the formula comes from. I don't know if you're really interested. It's some work there, but that is where the formula comes from. So it comes from rearranging your ax squared plus bx plus c into that square and then doing a square root to take the square root of the square, and then you end up at the quadratic formula. So, all right. So here's what the formula is. So the formula is, it's a gigantic fraction with lots of negatives in it. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, there it is. My geometry teacher in high school made us memorize that, and he would actually call on people to recite the quadratic formula, and I was terrified of doing that, so I learned it. Learned it because I was terrified. But there it is. Okay, now it's so much fun. Not really. It's what do we have here? We have a negative in front of the b. You notice that I said the opposite of b. Okay, you have a negative, so you have subtraction here. You have both, so that's great. That's that plus or minus that comes from taking the square root. We did talk about that before. And the whole thing is a gigantic fraction. You do want to make sure your fraction bar goes all the way across. If it gets shorter and shorter and shorter, it actually does change your order of operations. So there you have it. Now, important to know that A, B, and C are always numbers. So never, ever, ever, never, ever, no, not once, not never, ever, should you be taking an X and plugging an X in here. So X, we have X is equal to, this is all numbers. Okay, all of that is numbers. If you do not see a number in front of an x squared or an x, the number that's there is 1. Okay, if you see a minus sign, then it'll be -1. But we never ever are putting in x's or x squareds. I can't, I've lost track of how many times I've seen that. So how does it work? It's here you go. You identify A, B, and C. Now this may involve putting it in standard form. So standard form is this. It is ax squared plus bx plus c is equal to 0. So you're going to get a 0 on one side, and you'll have the ax squared plus bx plus c. It might be out of order. Make sure you put it in order. A is always going to be buddied up with your x squared. B is always buddied up with your x. C is always by itself. And you always, always, always need a 0. So if you've got stuff hanging out on both sides of the equal sign, we got to get it all together. on one side and preferably put it in order, okay? So you got to identify what those numbers are. Then you plug A, B, and C into the formula. Wherever you have an A, you put that number, B, you put that number, C, you put that number. And then you slowly and carefully use order of operations to simplify and find the values of X. Slowly and carefully. They can vary, these problems can vary in how much you have to do or how far you have to simplify it. So there's quite a little bit of latitude. I tried to keep the problems in this assignment on the more straightforward side. We will later on take a look at how you can use Desmos to evaluate this. The only thing that Desmos will do, though, is Desmos is always going to give you your answer in the form of a decimal, and sometimes you want the answer in the form of a square root. So that's like just a little caveat there. So slowly and carefully use order of operations. The more of these you do, the better you will get about the order of operations. Okay, so we have example 1. So we're going to work through, I think I've got 3 examples here. So we're going to just go through 3 examples together. So starting off with A. Now remember that number out in front of the X squared, that's a 1, okay? So the first thing we're going to do is identify A is equal to 1, B is equal to -5, and C is equal to 6. I would write down the formula. Now, there was a story years ago. A math teacher that used to work here used to tell a story, and it was actually one of the best ways I've ever heard to memorize the quadratic formula. Kids loved it, but it's not. We are like in a, I guess our culture right now is really, really sensitive, and it's not like dirty or anything. It's not anything like that, but it's the kind of thing that somebody would get upset about something in it, and so I can't share the story with you anymore. So that's a bummer. But all right, so we write down the formula. So the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. And now we're going to plug the numbers in. So carefully plugging them in. The opposite of B is -5. And so the opposite of -5 is +5. Now, a tip here, always put your B value in parentheses when you're squaring it. It won't always cause an error if you don't, but it does about half the time, okay, if you don't put it in parentheses. So it'll cause an error if it's negative, okay? So put it in parentheses. That's how we want it. -4 times 1 times 6 all over 2 times 1. So what I did there was I just plugged each of those numbers in where it goes. So B squared, B is -5, so it's -5 squared, -4, A is 1, C is 6, all over 2 times A was 1. I am okay with you taking a couple of shortcuts here. If you're multiplying by a 1, I generally don't care if you show me the multiplying by 1. So if you just wanted to write 4 times 6 there, that's fine. If you just wanted to write a 2, that's fine. I'm also okay with you squaring this in your head. If you're okay with squaring it, just know that a negative times a negative will be a positive. So you're always going to have a positive number there. And now we slowly and carefully evaluate this. So like I mentioned, -5 squared is 25. -4 times 1 times 6, that is 24. Over 2 times 1 is 2. 25 minus 24 is 1. And then the square root of 1 is 1. Now, sometimes if you still have a square root, we would stop the problem right there. Okay, if you still had a square root, but we don't have a square root, so we can actually keep going. And but we can't add and subtract at the same time. So one of the answers is going to come from adding, and the other answer is going to come from subtracting. So we're going to have 5 plus 1 over 2. 5 plus 1 is 6, and 6 divided by 2 is 3. So that's one of my solutions. The other solution will come from doing 5 minus 1. So 5 minus 1 over 2. 5 minus 1 is 4, and 4 divided by 2 is 2. And so the two solutions to that are x is equal to 3 and x is equal to 2. Now, what must you show for work? Yeah, that's not a super straightforward thing to answer. You do have to show, whoa. I thought I changed it to a highlighter, but I guess I did not. Okay. I don't even know. Okay, it's like not really showing up the highlighting. You can kind of see that it's like turning yellow there. I do want to see the substitution. And again, I am okay if you don't show the times 1, or if you like square the -5 in your head. So you could say 5 plus or minus the square root of 25 minus 4 times 6 all over 2. I would be okay with that. Now, from there to the end, like that's like really hard for me to tell you exactly what do I want you to show, because I'm not really particular about specifics. So I would be okay with you if you showed this and then maybe jumped to this, or if you skipped this but showed this. So I don't feel like you've got to show every single step, but you shouldn't be going from here down to the 2 and the 3. So I know that's probably not as specific as you would like. But this is where you do your homework. You can ask in class, hey, Miss Taylor, am I showing enough? So like, I don't necessarily think you have to show both the 5 plus 1 over 2 and the 6 over 2, but I think you should show one of them. So you could go 5 plus 1 over 2 and then jump straight to the 3, or you could go from here to the 6 over 2 and then to the 3, but we really shouldn't be going from here straight to the 3. So, do your best, do what you need to show, and then you can always ask in class, like, am I showing enough work to show that, like, I am the one that did this and I did not throw it into, Photomath. All right, next one. So this one is not in standard form. So this one's got the -5 on the other side. So a common mistake students will make, is they will say A equals 1, B equals 2, and C equals -5. They will just be like, oh, it's equal to -5. But remember, it has to be in standard form. So ax squared plus bx plus c equals 0, not equals -5. So before you can do that, so I'm going to go ahead and erase that because that is actually not the right number. You would need to add 5 to both sides. So you'd have ax squared plus bx, and then it's plus 5 equals 0. So your c value is equal to 5, not equal to -5. And of course, that will change your entire answer. It'll take a nice problem and make it horrible. Or a horrible problem, make it nice. Who knows? All right. And we do want to have this memorized. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then this is where I'm going to require that you start showing the work. So we have the opposite of b. B is 2. So the opposite of 2 is -2. Now, I strongly recommend that you put that in parentheses. Okay, now the parentheses here won't make a difference, but in the previous one, it would have. -4 times 1 times 5 all over 2 times 1. And again, I am okay if you don't want to put in those ones that you're multiplying by. Those aren't changing anything. And now we slowly and carefully carry out our order of operations. So 2 squared is 4. 4 times 1 times 5 is 20. Over 2 times 1 is 2. 4 minus 20 is -16. Imagine that. Okay, now a couple class periods ago, we would not have been able to do the square root of -6. 16, but we can now. Okay, so I'm going to do a little bit of scratch work off to the side and I might erase it, but the square root of negative 16 is the square root of 16 times negative 1. Square root of 16 is 4. Square root of negative 1 is I. And so the square root of negative 16 is 4I. And then this is actually pretty interesting. We can actually divide everything by 2. So the way this like works out is we got like negative 2 over 2, and then we do the 4I over 2. Negative 2 over 2 is negative 1, and 4I over 2 is 2I. And so the answer, like I've got it boxed in there. If you can't see it really well, you grab the... Okay, it's negative 1 plus or minus 2I. So if you're wondering, what are the two solutions? Like that looks really weird to me, Miss Taylor. Okay, now I know the screen's getting really, really crowded, so I apologize for that. One of the answers is negative 1 plus 2I, and the other one is negative 1 minus 2I. So those are the two solutions. So x equals and x equals. So now we don't usually write it like that. We usually write it as the negative 1 plus or minus 2I. We leave it that way. But in case you wanted to see what the two actual solutions are, it's negative 1 plus 2I and negative 1 minus 2I are the two solutions. So there's one that comes out with the I's, and that's why, if you're wondering, why did she like do the order that she did? It's so that when we look at the quadratic formula here, we can handle it if we end up with an I. So we do have to cover those I's first before we can do this. All right, last example. 2x squared plus 3x minus 4. So that one's already in the right form, which is nice. We have a is equal to 2, b is equal to 3, and c is equal to negative 4. And so our quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. There you go. Please make sure that you are writing it down correctly. I can't even tell you how frustrating it is as a teacher to have students get a bunch of stuff wrong because like they copied the formula down wrong every single time. Like we do not want to copy the formula wrong. And so I'll have students write like 2C on the bottom or minus 4AB. Go and look it up. Make sure you are copying it down correctly. All right, the opposite of b. So b is 3, so the opposite of 3 is negative 3. And then we're going to have 3 squared. Actually, for this one, well, no, we'll go ahead and do that. And then we'll have minus 4 times 2 times negative 4. So this is where we have a lot of sign stuff. And then we have 2 times 2. Okay, so looking in, this is, yeah. This is where we have so much fun with this. Okay, slowly and carefully evaluate it. So negative 3, there we go. Now, 3 squared is 9. Now, right here is where a lot of students will go astray. It's we've got a negative here and a negative here. Okay, so there's two ways you could think of it. You could do 4 times 2 times negative 4, which is what is that? That is like 32. I think. So it'll be minus negative 32 because 4 times 2 times negative 4 is negative 32. So it'll be minus negative 32 minus a negative is plus 32. Or you can think of it this way. Negative 4 times 2 is negative 8, and negative 8 times negative 4 is positive 32. Either way, this is a positive 32. And then 2 times 2 is 4. Very, very, very easy to make a mistake there. Okay, I'm not going to tell you that it's like that's super easy. It's easy to make a mistake. So go slowly, go carefully, go neatly. Do not cram all the work together. Do not try to do this in like some itty bitty space on your paper. All right, give yourself enough space to work with. Now, 9 plus 32 is 41. And actually, we would stop the problem there because I cannot take the square root of 41, and therefore there's nothing further I can do. It's not like the one at the beginning where I could take the square root. Sometimes you can simplify the square root, but I did, I was using AI to help me write the problems. So I tried to make sure that that's not how it would come out, because we haven't like really talked about simplifying square roots. Now, if you're wondering, well, what are the two answers, right? Because there's supposed to be two answers. One of them is -3 plus the square root of 41 over 4, and the other one is -3 minus the square root of 41 over 4. But we usually don't write it like that. We usually save space by writing it that way. The only time we split them up is if we're going to get two like integer answers, and it's much neater to split it up. So you have like a 2 and a 3, and you can carry it out. Okay, so those are basically the three cases. So you can see the ones that come out really nice and you can simplify it all the way. You can see the ones that have an I in them, and you can see the ones that leave it with a square root. And we could jumble this up a little bit more. Like you could have one that has a square root and an I in it as well. We could have ones where the square root simplifies a little bit, but the quadratic formula is it's a thing. All right. So try not to overcomplicate it. Now, the homework template. So I do want you to do this on a template, and that is just to emphasize how the work should be set up. So I dropped that off for copies this morning. And here's what the template looks like. So you're going to be given some equation like 3x squared minus 2x plus 4 equals 0, or some other variation on it. So we have A is equal to 3, B is equal to -2, and C is equal to 4. So you're actually going to tell me what A, B, and C are. That way, if you're getting your A, B, and C values wrong, and that's why you're getting the problems wrong, we'll be able to see very clearly that's what you're doing. Then you're going to see a quadratic formula with the main pieces, but none of the numbers filled in. Okay, and this is what you're supposed to do with that. You're supposed to do the opposite of B, so you're going to tell me the opposite of -2 is 2. So you're going to put a 2 there. Then you're going to put in here -2 squared minus 4 times 3 times 4. I think I might have even put the 4 in it on the worksheet, all over 2 times 3. So you're going to show me that you can get the numbers in the right spot. List your values for A, B, and C, substitute them into the template, and then slowly and carefully work your way to the solution. Write neatly. It's okay if you make mistakes. Okay, like there's a lot of steps involved in this, but we do want to be able to find the mistakes when you make them, which we cannot do if it looks like number vomit like everywhere on your page. Okay, so like neatly and methodically. And you must memorize the quadratic formula. So what is the assignment? Well, there it is. Solve each of these quadratics using the quadratic formula and show all work. Write your work on the provided worksheet. So you can tell a couple of them are already with the equals 0, which is great. So 3 and 4 are already in that form. The others have a little bit of stuff you need to do. So this one, we're going to need to get the 3 over. This one, it's the x term, so we're going to need to get that over. This one has both of them. You actually have a couple options on that one. So I'm interested to see what you do. You can take these and move them over to the left, or you could take the 3x squared and say, I'm just going to move that over to the right. It will come out the same way either way. So that's kind of up to you. One of the ways will come out nicer than the other, but they'll both give you the same answer when you're done. Only 5, because these are kind of tangly kind of problems. So, give it your best. You may use AI to check your work to see if you're getting the right answer for them, but don't use AI to do the work. So you work the problem first and then use AI to check it, and that will kind of stir whether or not we have or let us know if we have questions. As always, you guys know where to find me. I hope a lot of you are out there enjoying Ray Rally right now. I might go out and wander around for a little bit before I leave work, and I will see you guys next class.